So yeah, we've been quite active in the W3C over the past, let's say, 2 years to get an activity going about the Web of Things. And over the past 2 years, it was an interest group that we ran, basically to get web developers and thing developers together to look how we can do something for the IoT space, how to simplify application development, and see how we can kind of counter the fragmentation that we see in that space. So generally, what is the Web of Things? So everyone has heard of the Internet of Things. We are the Internet of Things Working Group. Usually the Internet of Things is mainly about the connectivity. So we have protocols to connect devices to some backend. We can connect devices independently. But on top of that, we still need some kind of application layer. And the situation today is that, there are many different platforms that provide an application layer, but they are basically silos. So they are made for a specific domain, and it's really hard to interconnect those. And what the Web of Things is aiming at, that we get a common application layer that is kind of equivalent to the web that we see for the normal internet today, so that we get some Web of Things that is overarching application layer where we can actually connect different silos together and fulfill actually this goal of having cross-domain applications in the Internet of Things. So we have network embedded applications for decades now. So, and actually a new big thing about the Internet of Things should be that we can connect these different domains together and get new aspects of how we, what kind of data we get and how we can use it and what we can automate with it. And in that sense, the mission of the W3C Web of Things activity is to interconnect the existing platforms and explicitly not to become yet another standard. But the idea is to counter the fragmentation in the IoT through building blocks that complement what's already there. So we acknowledge that there will be multiple ecosystems and standards out there, but we want to complement them to enable an easy integration across these different platforms. And so what are the key challenges and the ideas we have, how we're going to do that? So one thing is definitely to enable interoperability across the IoT platforms. That means the different protocols they speak. So depending on the domain, there is a different protocol. Examples are CoAP, MQTT, but also still HTTP, and so on. So there are also more specialized protocols like you heard OPC UA, which has a kind of a binary binding over TCP. So they are out there, and we want to enable interoperability across these different protocols. On the other hand, we also want to simplify how application development is done, and that it becomes more like the web programming model. So this includes to kind of change how IoT development is done, so that we do not have to be in this embedded domain to develop the applications, but make it more accessible for developers and can reach out to the huge resources out there who are web developers who can build these applications. And the side aspect is that we actually aim at thing-to-thing communication. So the overall architecture is not focusing on something. We have a device that we can connect to a cloud, but we can actually also have thing-to-thing interactions in the field, that we can have some local pre-processing, and that we can also put parts of the application actually down in the field, and that we have uniform interfaces on the devices themselves, the gateway level, and the cloud level. And the key thing how to achieve this is to come up with a simple but common interaction model that can serve as a narrow ways across these different platforms that are already there. And on the top, we want to standardize a scripting API that's basically like the web browser API we know today. So the web browser provides a runtime for web applications that allow to run in any kind of browser. So it's vendor independent and it's easy to deploy application code in the field. And we envision something similar for the Internet of Things, so that we have a runtime container where we can be sure that a piece of code will be able to run on this device. It can be moved, for instance, to a gateway and will run there as well. And the idea is here to leverage on what's already there in the web, to provide JavaScript, for instance, But we want to define these APIs in a language agnostic way, so that, for instance, you can also have Lua scripting that runs on really constrained devices. And on the bottom, we want to provide protocol mappings, so that we can support multiple protocols, for instance, HTTP, CoAP, MQTT, and so on. But we really want to describe how these protocols are used. So each platform, for instance, has a specific flavor of a protocol. For instance, there's CoAP is used in OCF, but then it's differently used in 1M2M. It's the same protocol, but they are not interoperable because they use different concepts, different payloads, and different semantic identifiers, how to describe the data. And to fulfill this kind of goal, we are aiming at building blocks. So those are individual blocks that can be implemented and then reused in different products, different application domains, and so on. So it's something that everyone can use and can also just use a part of it to fulfill a specific goal in a project, but then also to be standard compliant. And the idea is that these pieces can be shared as the overall idea of the Internet of Things Working Group here at Eclipse, that there are some common solutions that are not differentiating and they can be pooled in a way so that many companies can invest on them and we can reuse it in different projects. So that's how a thing usually looks like. You have some application code, then there's a platform-specific API, and you use some protocol. And to come to this common model I was describing, we have to look a bit in more detail what are the abstractions and what are actually the interfaces on such a thing. So it's a bit more complicated, and the main thing is that we have this narrow ways interaction model between the API and the protocol itself. And the building block we want to realize here is a so-called thing description. So this is basically a semantic description of how can I interact with this thing. And so it provides interactions for the API. So if I write an application, I can use that from my application code, but it also contains the information how is this then reflected on the protocol level. So I have an explicit explanation how does a message look like that I have to send to this OCF device or to this other 1M2M device. And overall, we also want to support metadata about the thing in general in this thing description, so that if I get the thing description, I learn about the context, what it provides, and how I can access this thing and interact with it. To provide the scripting API, we also, of course, need a runtime. So the application code becomes a script. And as I said, so the idea is here to have a browser-like runtime for Internet of Things applications, so that you can instantiate software objects that represent remote things, and I can interact with them through this narrow ways interaction model. And then the software stack will automatically create the message that is required to trigger the interaction that I called in my runtime. That basically gives the advantage of portable application code. So I already mentioned that we envision that you can use the same piece of code on the device level, the gateway level, and the cloud level. And it also should be able that, for instance, Amazon could write an application for fridges and doesn't have to implement it for each and every fridge from a different vendor, but writes it once. And there's this common API so that the key features that make a fridge can be accessed through this code. And what we currently sketched is a client API so that I can use remote things, a server API so that I can expose whatever I provide as a thing to other things, and also a discovery API to abstract how do I actually find out who is in my surrounding, who can I access, who can I talk to. And the third building block are these protocol mappings. So we really want to describe how to map these narrow ways interactions to messages. And basically that makes the protocol stack like an abstract message factory. So you have some description that you feed into the stack on top, and it will create you the message that will be understood by the device you want to talk to. And with these mappings, it also becomes easier actually to implement gateways that should bridge to different ecosystems. We, for instance, have a BACnet gateway that can discover whatever BACnet object is available in a specific network and automatically creates these thing descriptions so that clients for the Web of Things can directly interact with that. So they have no notion about BACnet, but they can learn how to interact with these different objects or devices that are available actually in the environment. And the nice thing is that this gateway automatically creates these descriptions, because we have a bridging ontology that understands the BACnet definitions and converts them automatically. So if we add a new device, we don't have to touch this gateway. And this automatic translation could help in many environments. For instance, we heard about the smart home project earlier, where we exactly have this problem. So at the moment, it's a lot of manual work and implementation to add new devices and add new features. And a notion of this is, so below these protocol mappings, we still see that there will be roles of a client and a server, but devices usually have both roles. So either they are a server, they provide some interaction functionality, or they have the drive to do something. So they have the initiative to actually call something, and then they are in client mode. But usually we find both of these roles on a device. And that's the reason within the W3C we call this construct a servient, which is kind of a new name, combined client and server. And what we also envision is that we can retrofit this thing description on existing devices. As I said, so that it's possible if we buy, for instance, an OCF device, we can write this thing description, and then we can use any kind of Web of Things client to interact with this device. So envision this also that we could write this, for instance, for Bluetooth Low Energy devices, so everything that is already deployed to enable a smooth transition, how to include these existing devices in the ecosystem. And a key point is that we want to enable actually semantics for semantic interoperability in the Web of Things. So you can see the thing description analogous to HTML, but for things. So we need some semantic annotations so that it really becomes machine understandable, so that, for instance, the machine knows which link to follow. So the human can read and then knows where to click, and there we need some special vocabularies that machines can do the similar thing. And here we actually want to be flexible, so it should be possible that someone kind of fully ignores what's out there in the semantic web, let's say, and what kind of tooling and partly really complex mechanisms are there, so that you just write this thing description and you're fine with it, but you have the possibility to include, for instance, already existing linked data vocabularies and ontologies that are already defined and are out there, and then get a lot of tooling that allows you to reason about a specific environment, can specific functions be fulfilled, is it a valid thing description, and so on. And the starting point for this is at the moment JSON-LD. It has the nice component that is basically a web-friendly notation of linked data, and it links to this RDF tooling that I mentioned. But you can just use it as a normal JSON document, so it's then similar to some JSON schema that is quite popular at the moment, so you don't have to really know about what's behind that. But the model we are defining is well grounded in this kind of semantic modeling. So this is not just a vision and an idea. So in this work, we actually try to follow this power of the IETF, so that we actually, alongside drafting specifications, we also implement that, so that we can actually base every decision on the need and the feasibility in code. So we really want to have running code alongside the specifications. And of course, this always helps to attract early adopters for some kind of new standard. And if you're interested, you can see us on Wednesday at the IoT Playground. So we have brought a few things that we already tested in several of these Bugfests, and you can see what we can do so far, and a bit more hands-on what all this means. So why am I here? So the idea is to actually have these building blocks that we want to standardize as available open source components. So it could be interesting to team up with the IoT working group and see what we can do. So the focus is really to have these cross-cutting technology elements, so something that is standardized and can be reused. And there are some ideas about possible projects that we could bring to the working group, so some kind of new projects. So for instance, parsers and generators for this thing description. Also quite interesting, the runtime environment. Or online tools, for instance, some generic clients that could run in a web browser where you can explore and discover an environment and then pick a specific device and, for instance, generate user interfaces for that based on the thing description. And we already have an open source project started at Siemens that we could contribute, but it's basically an early prototype, so it could be a starting point. But it's not anything that we have to adopt. It's something that could help with this. More interestingly, I find the possible collaborations with existing projects. So, for instance, Rono and Smart Home have this problem of many different devices to integrate different platforms. So maybe thing description support could actually help here. So that it's not just some internal specification, but something that's really standardized in the W3C. And I was quite happy to hear that Kapur targets this microservice architecture. And this is actually an idea that's also in the Web of Things. So in this runtime, all the functionality should be realized as some kind of microservice. And maybe there's some overlap here. And something we are looking for actually is MQTT mappings for the Web of Things. And yeah, I know that the IoT working group here is a fan of MQTT, so maybe we find some volunteers who want to help with that, who have experienced how MQTT is used in more complex environments and how we can kind of describe the usage of MQTT that it becomes possible for the Web of Things to be part of this. I want to conclude with a bunch of links. I think the slides, I give them to Ian later. Yeah, so you don't have to type this, you can then just click. The general structure is there are some landing pages by the W3C where you see mostly marketing material. Then we have a wiki where you find all the organizational information. So for instance, about the weekly call and the upcoming meetings. Then all the technical work is actually on GitHub. And we also provide the GitHub pages for the current documents, like the current architecture draft or the current practices, which is kind of a summary. If you want to implement that, what do you need to do, what do you have to know? And as I said, so we are an interest group in the W3C right now. There's a charter. And we are currently proposing a working group. It just went to this AC review, if someone knows what that is, and it looks quite good. So we got quite some support. So it's over 50 supporters for this activity. We have 2 comments that we need to address, but the plan is that we can start this working group actually by the end of this year. And yeah, if you have questions, please come and visit us on Wednesday at the IoT Playground, and there we're happy to chat. Otherwise, maybe there's some questions right now.
Yeah, just questions here. We still have time. Pat?
Well, of course, I have a question regarding your proposed integration with Ono. I'm not really sure whether I understood what you were proposing, so can you please elaborate a little? What do you have in mind there?
Yeah, so the overall problems are always the same, and the project defines some interfaces or a way how to solve things. And we try to actually learn how things have been solved before and find some common denominator that then actually can be standardized, and then these building blocks become of better use. So you don't have just, okay, I have to implement against this API, but I implement against the standardized API. So that these building blocks really become modular and can be shuffled around.
So do I understand that correctly, that you propose that Ono's API should be standardized by means of Web of Things?
So half-half. So the idea would actually be to get input from these projects. So what are you facing because you want to integrate different transports, different platforms, and you have to deal with that. So what is your experience with that? What was the best practice to deal with that? We're actually happy to hear about this, to be able to incorporate that. So as I said, the working group is just taking up its work end of this year, and then we have about 2 years to define the standard. So there's nothing set in stone. It's really about learning how this is done, and then kind of iterate on that and find the best solution that benefits both.
I think you and I will have to have a chat.
Okay.
Axel?
Just a quick question. How's it related to Eclipse model? If you model your building blocks or
yeah, so the idea is quite similar, so that you have some kind of meta model or the information model. Voto is kind of focusing on the code generation for stubs that you then include in your code. Here's the idea that you describe the network interface, so you don't need to modify the thing itself, but you describe how you interact with that. And ideally, you have a generic protocol stack and then configure it based on this description that it sends out the right message. So the example is you can use co-op, for instance, in many different ways, and that just based on this information, you create a co-op message that will be understood by that particular device. So there's a lot of overlap. Would also be interesting to hear what's there. Maybe the background. So this is basically coming from a different community. There's a lot of support from the Semantic web people who are interested in kind of combining their knowledge and machine-readable descriptions for the Internet of Things. And yeah, so this is again some kind of overlap where we could discuss. And if you're interested in getting something standardized, this could be an opportunity.
So did I understand that correctly, that you're thinking about generating or using the uniform network stack dynamically during runtime, parameterizing it or configuring it dynamically during runtime by means of this description? Exactly,
so that you know how, you have some configuration, like what method do you use and what is the payload, how is the payload organized. So it combines first description about the protocol in particular, like what options have to be set. And we are also working on some type systems so that we can basically annotate how the payload looks like. So if it's some standard serialization like JSON or CBOR or XE or something like that, that we know which elements are in there and what do they mean. So this is still a tricky part. There's a lack of kind of proper schema languages, so there are some starting points, but it's still hard to actually combine everything together. But yeah, the idea is to have something dynamic. So not that you have to generate code that then is only working for a specific platform, but you have one protocol implementation, then configure it for each message for the device you want to talk to.
In that case, you would have multiple protocol implementations. So everything would be able to, or would have a generic TCP stack, if you will, and you can dynamically configure that to produce an MQTT message or an HTTP message or whatever.
Yes. So that's the extreme view. So I don't believe that that's possible.
Neither do I.
So we start a bit higher. So we use actually application protocols. But for instance, if I take Californium, I can make it talk to OCF devices, and I can make it talk to 1M2M devices. And that I can do with just the API that's provided there. So it's then only a few configuration parameters. And these parameters should go in these protocol mappings. So it's really, the idea is not so you might encounter some people that say you have some metadata and then the code will write itself or something. I don't believe in that. It's really that you take something and you just configure it and it will produce the message you need.
So let's take one more and then we're going to have to move on. But Matthias is here all week, so there'll be lots of opportunity. So.
I guess this is influenced by the team at Everything. Are they planning to contribute code or?
So they were quite active when we started the whole thing. So I think 3 years ago or something there was a kickoff workshop. They were quite active in the beginning, but then they kind of backed out. So there were some reasons because it was like many different stakeholders coming together. It was more some kind of educational group there. But since last TPAC, they're actually back. And they again, try to support this and also want to make some contributions. For instance, They have some, I think, MQTT binding, or at least some WebSocket stuff that they want to put in there, and additional things.
Okay, thank you, Matthias.